You may remember last time we were together that we were given 3 points and tasked with trying to find an equation that would connect those points. And we found out that there, in fact, was a quadratic equation that, of course, made a parabola and went through those 3 points. But this begs the question, do 3 points always make a parabola? Maybe the 3 points that I gave you just were perfectly parabolic. What if somehow we could dig a little deeper and maybe try to come up with some random points? Um, would it still make a parabola? Well, let's find out. Now, normally I would do this activity with students in the classroom. We'd have a little fun with this, but we can still have a little bit of fun. I encourage you to make sure that you're participating and thinking as we go through this brief investigation. Now, it'd be nice if we could come up with some random points, like maybe blindfold somebody and just have them mark 3 points. Or what if I had maybe like some darts and I could throw darts um, at a board and use those as my 3 points? Well, it just so happens that I did.
Throw number one. Throw number two. And throw number three. All right, so how do we do here? We're going to use these as our 3 points for the parabola. Point 1, point 2, and point 3.
All right, now we're going to use as the 3 points that I threw on that dartboard as point number one being -9, 1. Point number two being -1, 5. And point number three, we'll pretend that was at 3, -7. So we tried to, as best we could, just kind of have 3 random points. Now, does it look like a parabola passes through those points? Well, if we were in class, I would have a student that thinks they knew try to draw the parabola. I'm just giving you a moment to kind of think on your own. Do you see a parabola? Does the parabola open up? Does the parabola open down? Well, that's right. It actually opens down. And there's a good chance that if I try to draw a parabola that passes through these points, that it's going to follow this basic parabolic shape. Now, just because we drew it, does that mean that it really exists? Well, not until we come up with an equation can we say, yes, it exists. So how do we come up with an equation for a parabola? That's right, we want to use this y equals ax squared plus bx plus c technique. Now, I'll tell you that it's going to be in your best interest to practice this with me. This is also to serve as another practice problem because there will be a time that you see one of these on a test. So do you want to pause the video and see if you remember how to plug in these 3 points? Or do you want to keep watching and follow along at the same time? Because you're going to find me plugging, well, -9 and 1 in for x and y. Now, of course, that means that I'll plug 1 in for y, but I will plug a -9 in for x. And then I'm going to do the same thing with the next point. I'm going to plug in a 5 for y, but we're going to plug a -1 in for x. See how that works. All right. And then the last one in a similar fashion. Now, when we plug these 3 points in for x and y into our y equals ax squared plus bx, it's supposed to be an x there, plus c, when we plug these 3 points in, we end up really creating a system. And this system just needs to be cleaned up a little bit. Of course, the first equation, when it cleans up, really ends up as an 81a, a minus 9b, a plus c, and a 1. The second equation, when it cleans up, actually gives you a positive 1a, but a minus 1b plus c, that equals 5. And then the last equation, looks like it's going to be a 9a, a 3b, and a 1c, equaling -7. Look familiar? Of course, this is just our infamous matrix. That is our matrix, magic matrix A, and our magic matrix B. Good time to practice popping those back in your calculator for matrix A and B. Now remember, if we're able to solve this system, then we're able to find the values for A, B, and C. And if we're able to find the values for A, B, and C, then we should be able to come up with an equation. Can you come up with that equation? Okay, once you put those numbers in for A and B and you do the magic A inverse times B formula, looks like you end up with these three values. Nobody said they were going to come out to be integers, but we can change them into fractions. And so it's kind of looking a little more sort of useful. Negative 7/24, negative 29/24, and 23/8. Now those three numbers would make up my equation. So I want to take those values and I want to write an equation in that form. So y equals negative 7/24 x squared minus 29/12 x, and then of course 23/8. It looks like an equation, kind of smells like an equation. Does it create a parabola that passes through those 3 points? Well, you can check it out. You can type that into your y equals screen carefully. And when you type that into your y equals screen, you graph it and you actually do get an upside down parabola. Now, does that upside down parabola really pass through those 3 points? Well, I'm going to wave my magic wand and we're going to take our parabola and we're going to find out that in fact it does. It should. It does pass through those 3 points. And so we seem to have another success. We seem to have another yes. 3 points really do make a parabola, even if they were kind of random. Now, it turns out that the answer is yes, with 2 exceptions. And as our final thought, there are actually 2 ways that I could randomly or purposely plot 3 points that would not make a parabola. Can you think of one of the ways? We want to put 3 points down, but we're not going to get a parabola. Right, if those 3 points are in a line, you mean if they're collinear. And it doesn't really matter what slope the line is. If those 3 points are collinear, there's no way you're going to draw a parabola. I mean, you can try to draw it upside down, but obviously that section right there gets pretty flat. And so that's not going to work. And I can try to draw it going up, but yeah, if 3 points are collinear, that's not going to make a parabola. And there's one other sort of there's one other exception. If 2 of the points are in a vertical line. Now, if 2 of the points are in a vertical line and you try to draw a parabola, again, I can sort of make it pretend that it's a parabola, but when these numbers get plugged into the matrix, and by the way, just the same as when all 3 of these numbers get plugged into the matrix, we're going to get one of those singular matrices. In other words, a no solution system, which means that we're not going to be able to come up with coefficients A, B, and C, which means there's no equation. So 3 points collinear, 2 points in a vertical line. But other than that, in general, yes, 3 points make a parabola. And this is like a mathematical fact. It's something that I want you to know and sort of put it in your tool belt of interesting ideas as we walk through this second half of the year with some more study on algebra.